Okay, folks, last section of this stuff before we take a test on the supplemental information for the IC, okay? Now, a singular matrix looks like this. It's the way we spell it. The plural of matrix is matrices, more than one, okay? This is one matrix, okay? These are equivalent matrices, all right? So, just to make you sound like you know what you're talking about, there is a difference in the plural. It's not matrices, it's matrices, okay? Now, a matrix is a rectangular arrangement of numbers into rows and columns, all right? I don't know if there's another kind of row. I assume that all rows are horizontal. If they're vertical, I call them columns, okay? Like columns on a house, right? Okay, columns go up and down, they're vertical. Rows are horizontal. Now, when we describe a matrix, we always describe it by reading the number of rows first, okay? How many rows are there in this example matrix right here? Parker A.
4.
I'm sorry, rows.
I read
3 rows, right? Here's 1, 2, 3 rows, okay? And how many columns are in this first matrix, Taylor? There are 4 columns. So we would say that this matrix is 3 by 4. That's the way we would read it, okay? Now, the reason that we talk about that is because if we're going to add and subtract matrices, they have to have the same dimensions, 3 by 4. If I were going to add another matrix to this, I would need a matrix that was 3 rows by 4 columns for us to add or subtract them, okay? And that's what we're learning to work with today, all right? Now, let's just look down at this last bit here, okay? 2 matrices are equal if the entries in corresponding positions are equal, okay? So this matrix is equal to this matrix because their entries are the same even if they're written in a different form. Let me ask you this. What are the dimensions of this first matrix, Cecilia? That one.
3, -2.
No, not the entries. What are the dimensions? Did I say entries?
Yes,
I'm sorry, I meant dimensions. What are the dimensions of this first matrix?
2 by 2.
2 by 2, right? 2 rows by 2 columns, right? What about this one that it's equivalent to?
2 by 2.
It has to be 2 by 2 if they're equivalent, right? 2 rows, 2 columns. Excellent, okay? Now, if I look in this first position, right? Top row, first column, I have a 3. Same thing with this one, okay? -2, I've got a -2 in the same position in that other matrix. This one gives me 1/2. Does that make it not equivalent to this one right here, Emily? No. Different form, but equivalent values, all right? And then 0, 0. So these 2 matrices are equal to each other, all right? Now, let's go back to, or let's look at these 2. This first matrix is not equal to the second one. Even though all the numbers in each matrix are the same, why are they not equivalent? Parker A.
Because the numbers are in different positions.
They're in different positions, okay? All right? Now, matrices are used to organize data. They make it simpler. I mean, we organize it and then they make it simpler for us to just run through it. An Excel spreadsheet is really based on matrices, okay? It looks at different rows and columns and adds things together. You have to tell it what position to look at and what to do to it, what kind of operations to do to it, okay? Now, let's look at number 1. Example number 1 says, write a matrix to organize the following information about your CD collection. How many of you use CDs? How many of you have ever seen a CD? Okay, good. At least we still know what they are. Okay? Now, this says your CD collection. In country, you've got 4 groups, 4 country groups. You've got 6 solo country artists, and you have 0 collections of all-time greatest country hits or whatever, okay? Now for rock, you've got 8 groups, 3 solo artists, 3 collections. Blues, you have 1 group, 5 solo artists, and 2 collections. Now, I can't finish